Surface area was everything on the outside. Now we're diving, I should say, inside the figure, right? So volume, space. Okay, I definitely don't want to start that way. Space occupied inside a figure. And I wanted to talk about a concept right now that's called Cavillaries Principle before we get into prisms and cylinders, all right? And I believe it's called Cavillaries because that's the gentleman who founded it. Here's what it says. You take any solid, if two or more solids that have the same height, okay? All of these have the same height. I can adjust the height if I want to, all right? They all have the same height. Any two or more solids that have the same height and their cross sections have the same area. So everyone see, even though this is a triangle, maybe a rectangle, parallelogram, I don't know, and whoever knows what that is, all right? All three cross sections look different, but they all have the same area. In that case, all the areas are the same. Cavillaries Principle says if figures have the same height and the same cross-sectional area, they all have the same volume. They all have the same volume. All right, so take a look. Still has the same volume as the other two. Okay, still has the same volume. Still, all three still have the same volume. Even though they're not standing straight up perpendicular to the ground, they all have the same volume. As long as the heights are the same, and like I said, the cross-sectional areas are the same, the volumes are all the same. And you can see I have a couple examples here, especially my pizza boxes or cardboard boxes, whatever they are. No matter if they're stacked straight up vertically, they're leaning, or just a hot mess, they all have the same volume. Okay, because the heights never change, and if I took a cross-section and found the area of all three, they'd be the same. Another classic example here. Do I think I still have it here? You guys get to creep through all my pictures now. There it is. Are the coins stacked right on top of each other? Same volume as if I kind of slanted it like the Leaning Tower of Pisa there. All right, why are they the same volume? Because Cavillaries Principle says that if they have the same height, same cross-sectional area, volumes are the same. All right, and I harp on that because usually I spend about a minute on it every year, and last year we got caught because it was on the Regents exam, and kids were like, we never did Cavillaries Principle. And I was like, yeah, we did it for about a minute on May 23rd. All right, so it does come up. All right, it did come up last year on the Regents exam. So everyone all right on Cavillaries Principle? No matter what the figure looks like, slanted, stacked straight up, hot mess, as long as they have the same height and same cross-sectional area, the volumes are equal. All right? All right, what about the volume of a prism? Do you still have your reference sheet on you? If you don't, there's one provided in the back of your packet. All right, if you do not have your own reference sheet on you from earlier this year, you'll see one in the back of your packet, I believe we put one. I hope. You'll see one right before the answer key. Did we put one in there? There it is, yep. Okay, so there's your reference sheet. The great thing about the second half of this unit is all the volumes we're gonna need are on there. And if you see the volume of a general prism, it says what? Whoa, not only does it say BH, it's capital B. That must be pretty darn important, huh? Capital BH. All right, well, I think we can take care of H real quick. H is going to be height of the prism, height of the prism. And I've been describing this all unit long. The height of any prism is the distance between its bases. All right, how far are the bases from each other? Now, big B, area of a base. Not area of both bases, area of a base. All right, area of a base. So identify what the base is, find the area of it. That's big B. All right, big B. All right, so I just want to make sure we can identify what the base is in each type here. What type of prism is this? Rectangular prism. So the base, this is a rectangular base. I just want to make sure. We understand what the bases are. What's the next type of prism? Triangular prism. So this would be a triangular base. So again, if I was doing the volume, I would find just the area of one of these triangles and multiply it by the height. Okay. And what about this last bad boy? Hexagonal prism. So it's a hexagonal base. Are we okay? Hey, in all seriousness, are we okay? Because it's going to get a little tougher here. Are we okay identifying what the base of a prism is and the height? Okay, let's go to cylinder then. Don't look on your formula sheet. I know it's on there. Don't look at it. Don't look at it. It's also big B times H because it's a type of prism, remember. A cylinder is a type of prism. Here's what I want you guys to do. Hopefully you didn't cheat already and look. Can you guys get a little bit more specific than big B times H? Can you replace something for big B? Remember what big B means. Area of the base, and it's a cylinder. Let's go, Ella. What do you got? Pi r squared can go in for the base because that's the area of a circle times the height. If you want to look on your reference sheet now, that's exactly what your reference sheet says. Volume of a cylinder, pi r squared times the height. All right, so volume, prism, and cylinder today. All good? All right, so help me find the volume of this prism. Your turn to take over. 25. What shape is the base up here? It is a triangle. So everyone, here we go. So I'm going to do 1/2 base times height for that triangle. So what is the base and the height of the triangular base there? 12. What are the base and the height of this triangle? So 8 times 15. Everyone see what I have in brackets here? That's big B. That is big B. Times the height of the prism, not the height of the base. Height of the prism. What is the distances between the two triangles right now? What is that distance? Here you go, 18. What's that distance? 8. Yep, right here. That's the height. So my volume here. $480. Welcome to volume today. Cubic meters, yes. When we're dealing with volume, cubic units. Yeah, here we go. Identify the base here of this prism. What shape is the base here? 25, shape of the base. A resident expert on shapes of the base. Yep. But unfortunately, it's not a right triangle anymore, though. Shoot! So it's still going to be 1/2. Anybody know what this other edge is here? 3, because that one's 3, yep. So no matter what you guys pick as the base of the triangle, it's going to be 3. Now I need your help. How do I find what the height is on that triangle? Got enough knowledge. There's a lot of different ways we could do this. It's up to you, though. What is the height of that triangle? Not the height of the prism, height of the triangle. Woo, 9. Any thoughts? Okay, you can. Here's my issue, and maybe you can help me, Braden. I see a right triangle, but I only have the hypotenuse. I need at least another leg to do Pythag. Okay, that's split. Any isosceles or equilateral triangle, the altitude is also a median, so that's going to be 1.5. Braden's going to use Pythag. Anybody else doing it a different way? Because it is an equilateral triangle. Jack? The 60 would be right here. Yep, there's your 60, and your 30 would be up here. Okay, you guys that are doing Pythag, you can keep it in the radical if you want, or write out the full calculator display. You guys that are doing 30, 60, 90, that's what I'm going to do. So I know my height's going to be 1.5 radical 3. But again, if you guys are doing pi fag, that's fine. Just make sure you keep it inside the radical or write out the full decimal. Do not round that decimal. And finally, what's the height of the prism? Height of the prism, 7. Height of the prism up here? 9. Yep, distance between the two triangles is 9. I didn't have any rounding direction, so we're going to go Regents mode and write it all out. About 35 and change. Questions, comments? All right, I'm going to let you guys do the cylinders in your group. And then we'll do this hexagonal prism down below together. Just make sure you leave 3 and 4. Let's do this. Make it easy on ourselves so we don't have to write down all these decimals. Just leave your answer in terms of pi. Okay, for 3 and 4, leave your answer in terms of pi. Okay, here you go. What did you guys end up getting? Help me plug in for the formulas. Here you go, 19. Volume formula for 3. Volume equals pi. Good. Half of 11 squared. Height of it? 16. In terms of pi, what'd you get there, Maya? 44? Okay, calm down with the attitude. 484 pi feet cubed. Anybody else hear that too? 484. Don't correct me again. 27. How about the pi radius here? Squared height. And how about the total volume in terms of pi? Okay. All right, ready to roll on the hexagonal. You guys are never getting away of finding the area of these, are you? What's the height of, first of all, what's the height of this prism? 8 is 8, so that's going to be plugged in for H. Now we got a little work for big B. I'll do it off to the side. So big B is going to be 1/2 AP. I'll ask somebody the easier question first, which is what's the perimeter of this hexagon? 25? 36, 6 times 6. All right, little, we just went over this in the homework, I believe. Creates a 30, 60, 90. Splits the base in half, so that's a 3. So whenever you're ready, what would the apothem be then? 15, what would the apothem length be? 30 is across from the 3. 3 radical 3. Hey, we're in honors, right? That's what they tell me. Can we leave this in simplest radical form instead of decimals here? Think we can handle that? You can get that radical 3 in your answer. Oh boy, I'm asking a lot. So 1/2 times 3 radical 3 times 36. That volume is going to be something radical 3, right? What do you got there? 10? Amanda, don't. It was just like 2. I was just thinking, is that the number? Is that the number? Is it 10 or 11? Is that the number? And he's not here. 3. And then you had to multiply it by 8, right? 54 radical 3 is what the area of the base was. And then 54 times 8. There you go. 432 radical 3 inches cubed. Yep. All right, you thought they were going away because we were doing volume now. It's surface area. And just like clockwork now. What else am I missing? Yeah, that's the same as swipe for me. Fade. Well, pinwheels, can't forget those. Drop. Cube. Clock. Think we covered them. So here we go. Star. Genie. Shatter. Curtains. Swipe. Page curl. Flip. Fade. Pinwheels. Drop. Cube. Clock. Okay, you ready? So we're going with curtains. Curtains and the man. Here we go. So we can get through these two. Everyone ready? Curtains and Promethean man. Whew, this would mean no homework for the rest of the week, huh? Ooh, there was I'm sorry. There was nothing there. I'm sorry. I forgot that was the last slide. All right, let's try this again. Everyone ready? Curtains. Ooh, that one was, I don't know, what do you call that one, huh? Stop. I'm sure somebody's been writing down every single page turn effect since September. I doubt it. I'm sure it's happened. All right. Okay, here we go. Sorry, homework's still due on Friday. Now, like I said, you thought they were gone because we're doing volume, but these figures with another figure are still there, but there's some good news now. If I'm asking for volume, I'm asking for the space inside. So do you have to worry about what's covered up anymore? No. You can just say, oh, it's a half cylinder and a prism. Done. I add them together. Don't have to worry about what's covered up. Speaking about what's covered up, remember you got 2 of them tomorrow. Find the surface area of 2 of them tomorrow. All right, but unfortunately, I don't think your reference sheet has the volume of an L on there. I don't think it's going to be on there. How to find the volume of an L. How can I chop this bad boy up now? How do you want me to chop it up into 2 figures I am familiar with? 2? Any ideas? You want me to chop this up? Would you like to make a vertical or horizontal line? Vertical. Okay, you got it? So I'm just going to call this number 1, and I'm going to call this prism number 2. Okay, so volume of number 1, what would be the base here? I know it's 2 by, what about this part down here? 2 by 4, yep. And how about the height of that prism right here, number 1? The height would be the distance between these two bases, 8. And I get this question every year with, how do you know what the base is? To be honest, guys, I'll tell you the truth because we only have a couple weeks left and I'm not going to hide anything here. It doesn't matter. Because let's just say you said this 8 by 2 was the base. What are you going to call the height now? 4. So you see what I'm saying? You're going to end up multiplying all 3 numbers anyway with volume. All right, of a rectangular prism anyway. So this comes out to be 64. And how about number 2? Let's see, number 2 will be, let's see, if I count the base as the bottom there, what's that, 2 by 2 with the height of 3. So the volume of that one is 12. So the total volume for this L-shaped figure, what do we got, 76, if I could add correctly, cubic feet. You champs that are going on to this next one here, can you just calm down 1 second for me? Can you change this 12 to an 8? Because if you don't, half the class will get an answer, half the class will get another answer, and they'll both be correct, unfortunately. All right, I'll show you why I needed to change that 8 in a second. All right, what's this made up of? Don't say a cube, it's not a cube. Dimensions are different. It's a half cylinder with a rectangular prism. And remember, we're not finding surface area. I don't care that that face is being covered up by the half cylinder. It does not matter to me. I'm filling the inside up. So it does not matter what's covered up. So the volume of the rectangular prism, 11 times 6 times 8. The base is 11 by 6 with a height of 8. And then up top, 1/2 pi r squared times the height. Now, what would be the radius here? What's the radius of that cylinder? Should be 4. And that's why, do you see how I had to change it to 8? Because some of you would have said 6, some of you would have said 4. All right. Questions on why it's 4. You can go 15 minus 11. That gives you the radius. Or, this whole side here, this edge is 8. Half of it would be 4. Now I'm interested, what's the height of that cylinder? Height. Distance between the two circles. Distance. Just find it first. Find where that distance is. It's right here. Here's the distance I'm talking about in red. That's the distance between the two bases. What's its measurement? 6. Yep. Anything up here you want? Where did that number come from? Ask now. Yep, Nate, go ahead. The height, 6? Okay, remember what the height is. The height is the distance between the two circular bases, right? Here's a circular base and there's one in the back, right? The edge that connects them is this red one. So that's considered the height of the cylinder. And again, if that's 6, that's going to be 6, that's going to be 6. Good? Good question. And what are we rounding to? Nearest whole number? We're going to end this on the right note. 13. Thanks. No, son? You all right? Do you have the same numbers? Would you type in your calculator? Remember, this is due on Friday, this homework. Tomorrow, you guys will walk in and take the quiz.